Now we're going to understand how we can verify the law of conservation of energy. Well, physics is a kind of subject that not just give you the idea about the laws and theories, but also tells you how we can verify the theories. So in your syllabus, we have this free falling body case from which we will verify the law of conservation of energy. So let's consider the first of all, let's consider body. And this body, suppose this body is at a point A. It is a point A, and the body, suppose the body is having mass m, and now body is just dropped. So when we are dropping, we are just dropping, so the initial velocity will be 0. That means the at point at point A, kinetic energy of the body will be 0, because the velocity is 0 and the kinetic energy will be 0. Now we can say it is at a certain height from the ground, h, from h height it is. So the potential energy will be mgh. M is the mass of the body, g is the acceleration due to gravity, and h is the height where we drop the body. Okay, so total energy at the point A, we can say total energy, that is Ke plus Pe, will be 0 plus mgh. That means the energy is mgh. So law of conservation of energy says that the total energy will remain same. It remain constant. So we have to verify that if it is constant at every point, then we can say law of conservation of energy is proved. So at this point A, we have seen the energy is mgh. Now we're going to understand what will be the energy at point B, or the another point. So let's see, suppose this is a point B, and if the body is falling from point A to B, that means it will have certain velocity and it will reach certain distance. So we can say the distance is x. So from the ground, this distance will be h minus x. So you can see it is a certain height, so it will have the a certain potential energy. And if it is falling at this point, it is not stopping here. That means it will have certain velocity. We can consider the velocity maybe v. Okay. So what will be the kinetic energy at this point? The kinetic energy will be half mv square, because we consider the at point B. At point B, we are considering at point B, the velocity of the body is v. So the kinetic energy will be half mv square. Now what will be the potential energy? Think about the potential. So from the ground we will take, so from the ground, this is the height where the body we kept. So potential energy is mg, and the height will be h minus x. Okay, so we can write down mgh minus mgx. Now we can convert this velocity value, we can convert. We know linear equation motion, that is v square is equals to u square plus 2as. Now v square, the velocity at this point, we consider the v, so we can write the v square. Initial velocity, we know it is 0, so we'll write 0. Okay, and we know the acceleration due to gravity over here is g. What is the distance this the body has traveled? So it traveled from A to B, traveled the distance x. So we, instead of writing s, we can write x. So v square, basically it will be 2gx. Now we can put this value, in this equation. Okay, after putting the value, we can write kinetic energy will be half m. Instead of writing v square, we can write 2gx, and we can cut down 2, then it will be mgx. Now we have to find the total energy. So total energy is Ke, kinetic energy, plus potential energy. Now this kinetic energy, we have come to know the value is mgx, and this potential energy plus mgh minus mgx. Now we can cut down this mgx because one is in the plus, another one is in the minus, so we can cut down. Now the total energy is coming mgh. Now in the previously we have seen total energy at the point A was also mgh, and the point B is also mgh. That means the total energy now remain constant. Now we have to find at the point C where the ball or the body is about to touch the ground. So if it is touching the ground, that means almost the kinetic energy, the potential energy just touching the ground, that means the height over here is zero. So this means that the potential energy at this point will be zero, and the body is about to touch the ground. That means the velocity will be maximum, so the kinetic energy will be maximum. So we have to find the kinetic energy over here. Okay, so let's suppose at point C we're finding at point C. Okay, so at point C we can say over here that potential energy is zero, so we can PE, we can say zero. Now we have to find the KE over here. What will be the KE? Suppose half m v dash square it is striking with a maximum velocity. Now we have to find out the value of v dash. We know from the linear equation v square u square plus 2 as. A is the acceleration, as this displacement. Okay, so v dash square it will be 0. 2, instead of writing a we can write acceleration due to gravity. And the distance from A to C is, we know, h. Total distance it travel from the ground height h was there. So we can write, instead of writing s, we can write h. So the v dash value will be v dash square value will be 2gh. So instead of writing ke half mv square, we can write half m and the value of v dash, which is 2gh. Now cut down this 2, we will get mgh. So the total energy at point C again, PE plus Ke, and that will be P0 and K is mgh. So we can write down mgh. So what we have seen in the all cases at the point A, it was mgh, and the point B, it was mgh, and at the point C, it is mgh. So you have seen what the total energy throughout the time remain constant. We have understood, we have actually calculated the value of total energy at the three different points. We can find out the value of total energy at n number of points, but the result will come same. So we can say the total energy was over here is the same, it was the constant, and here it is constant, and here it is constant. But what you have seen over here the kinetic energy was zero, Ke was zero, but the potential energy was maximum. Here the kinetic energy was not equals to zero, and neither the potential energy was not equals to zero. So you are seeing that some potential energy has transformed into kinetic energy. Okay, and here what we have seen, when this body was about to touch the ground, potential energy was zero, but the kinetic energy was maximum. So we have understood that the energy is transforming from one form to another, but the total energy, the total value will remain same. So that is what the law of conservation of energy says, if you have seen the previous video. So we can say that if we will draw the graphical representation of this case, we can say, we can take, suppose this is the energy, and this is the distance we are taking, total distance h, and this is the energy we are taking T. So suppose this is the point A. This is the point A where the potential energy PE was maximum. And here at the point A, PE was the max. And KE at this point was zero. Now when it started producing a certain displacement, means it is falling down. So potential energy was decreasing and the kinetic energy bit increasing. So at this point, kinetic energy is zero. Okay, so kinetic energy, you have seen the slowly increasing like this, and potential energy was slowly decreasing. When it reached the height, which reached the ground, it becomes zero. So the graph of potential energy and kinetic energy will come like this, but the total energy will remain constant throughout the distance or throughout the time. Even the time or distance, both we can take. So we have understood the graphical representations also, and we have understood how we can prove the law of conservation of energy with the help of free falling body. In the next lecture, we will understand how we can verify the law of conservation of energy with the help of, in the case of pendulum. Thank you so much.